Okay guys, so this is some new material that we are going to discuss, and it ties into this idea of rewriting a mathematical sentence in a different way so that it means the same thing. And particularly, we're going to deal with exponential equations. So before we get started, I want to do a quick review of some exponential rules. For example, if I have 2 to the first, and I'm multiplying that by 2 cubed. When I multiply two terms that have the same base, then I add my exponents, so 1 plus 3, or 2 to the fourth. All right. When I divide 2 cubed divided by 2 squared. When I divide those exponents, remember I subtract them, so 3 minus 2 gives me 2 to the first. If I have a negative exponent, remember a negative exponent means that I'm going to move that exponent to make it positive. I'm going to move it into the denominator, so that becomes 1 over 2, or 1/2. Same thing if I did 1 over 2 to the negative 2, this would be 2 to the positive 2, or 2 squared, excuse me. And then finally, our last rule, anything to the power of 0 is 1. And there's a lot of cool videos out there that actually explain why it equals 1, but just for this video, we're just going to remember 2 to the power of 0, or anything to the power of 0 is 1. So we're going to use these to kind of give us our basis for how we're going to do these problems. So I'm going to start off with an equation here. So let's say 5 to the x plus 3 is equal to 25 2x plus 1. Okay. So when we have exponential equations, we are going to use a rule that says if I have two terms where the bases are the same, but the exponents are different. If my bases are the same, but my exponents are different, so both of these have a base of a, then I can say that x is equal to y, or that my exponents are equal to each other. But here's the thing, my bases right now aren't the same, but if you notice, my bases are actually very similar, because 25 is the same thing as 5 squared. Those are equivalent. So I can actually do some rewriting. I can say that this is 5 to the x plus 3, and this is 5 squared to the 2x plus 1. And before I move ahead, I forgot a rule above here. If I have a power that's being raised to a power, remember this becomes 2 times 3, so I multiply to give me 2 to the 6th. So now I have 5 to the x plus 3 is equal to 5. Now when I multiply, I have 2 times 2x plus 1, so I need to distribute. So this becomes 4x plus 2. So now my bases are the same. They're both 5. So that means I can solve by setting x plus 3 equal to 4x plus 2. And now I have a two-step equation, so I'm going to subtract 2, subtract x, and I have 1 is equal to 3x, or x equals 1/3. Okay? Alright, so I'm going to add a picture here. Let's do one. So we're going to try another one. So solving for x, we have 9 to the 2x plus 4 is equal to 81 to the 3x minus 4. So again, we're using this property that we're trying to make our bases the same. So I noticed that we have a 9 here and 81. Well, if I know kind of perfect squares, I know that 81 is equal to 9 squared. So I'm going to rewrite this as 2x plus 4 is equal to 9 squared 3x minus 4. And I have 2 here, so I got to distribute that 2. And now that my bases are the same, so both of these are now the same, I have 2x plus 4, 6x minus 8, and 12, 4x, x equals 3. All right. And we'll do one more. I'll let you kind of work this one on your own. See if we can do this. Should be pretty straightforward. Kind of had the same one above. Make this a little bigger. So my bases, it looks like I'm going to change 25. So I have 5 to the 2x plus 2. We can change 25 to become 5 squared. 5 to the 2x plus 2 plus 5 to the 4x minus 2. Now that my bases are the same, and let's see, now I can combine like terms. So 4 is equal to 2x, or x is equal to 2. All right. So I'm going to leave you guys with that as kind of our exit ticket. I will post one more problem for you. And this one might be a little complicated, but it requires, all right, some extra solving. And to check the answer for this question, our solution set is -8 and 5. So I'll let you work on that one, and you are always welcome to ask us questions, and then that is what your exit ticket is over. All right. Well, thank you guys.